Welcome to today's Explainer. We're diving straight into what is, honestly, the ultimate cosmic mystery. It's a concept that's totally fueled our imaginations, right? It's inspired countless blockbuster movies and literally kept the world's most brilliant physicists wide awake at night. We're talking about time travel. So, is it just magic and science fiction, or could it actually be a real, physical possibility hiding right there in the math of our universe? Let's find out.
I really want you to imagine, just for a second, having the ultimate power. What if you could step into a machine, hit a button, and actually rewrite history? Like, would you go back and watch them build the pyramids? Or maybe leap forward to see what humanity looks like 1,000 years from now? Or, maybe you'd just try to undo a personal mistake. It's a completely fascinating question. But to figure out if it's actually possible, we've got to look at the science.
Section 1. Is time travel possible? The cosmic detective story. Okay, let's dive into this. To solve this grand mystery of time, we first have to understand how our view of it has totally shifted. You see, time travel started out as pure fiction, like when H.G. Wells wrote The Time Machine, way back in 1895. But then, just 20 years later, Albert Einstein comes along with his theory of general relativity and completely changes the game. He proved that time isn't just some ticking clock sitting in the background, it's an actual physical dimension. Fast forward to 1949, and this brilliant mathematician Kurt Gödel takes Einstein's own math and proves something absolutely mind-blowing. He showed that if the entire universe were spinning, space and time could actually twist so much that they loop back on themselves. So suddenly, traveling to the past wasn't just a fun story anymore. It was a real mathematical possibility.
Section 2. Fast forward, the future. Traveling forward is proven science. Believe it or not, traveling to the future isn't just a sci-fi trope. It's a proven fact of our universe. To grasp how this works, we need to talk about time dilation. So, instead of picturing time as this invisible, steady tick-tock, I want you to think of it like a giant, super stretchy rubber band. If you move incredibly fast, or if you get really, really close to something with super strong gravity, like a massive planet or a black hole, that fabric of time actually stretches out. And because it stretches, for you, time actually slows down compared to everyone else.
This brings us to a really famous scientific analogy called the twin paradox. Picture two identical twins. One stays right here on Earth, just chilling out in normal gravity. The other twin hops into the super-fast spaceship and just zooms off across the galaxy at nearly the speed of light. Now, because that spaceship twin is moving so incredibly fast, their time fabric stretches way out. When they finally fly back and land on Earth, they might have only aged, say, a few weeks. But the twin who stayed behind on Earth, they might have aged 10 whole years. The spaceship twin has literally traveled into Earth's future. Crazy, right?
And this brilliantly illustrates that this time travel effect isn't just some abstract thought experiment. It's happening right now, right above our heads. Those GPS satellites orbiting the Earth, the ones that power the maps on your phone, they're moving super fast and experiencing less gravity than we do down here on the ground. Because of that, their clocks actually run at a slightly different speed than our clocks on Earth. Scientists literally have to mathematically correct for this time dilation. If they didn't, your phone's GPS would fail completely in a matter of minutes. So in a tiny, microscopic way, your phone is actually dealing with time travel right now.
Section 3. Tunnels to the past. The mystery of going backwards.
So, zipping into the future? That's a proven reality. But what about the other direction? Well, going to the past is where physics makes things incredibly tricky. While going to the future is achieved just through high speed and gravity, the math tells us that traveling to the past requires things we aren't even 100% sure exist yet. Stuff like exotic matter with negative energy, and these massive, crazy shortcuts through the universe called wormholes. In the physics world, a trip to the past goes by a very fancy, intimidating name, a closed time-like curve. But honestly, you can just think of it like a cosmic roller coaster track. Imagine getting on a roller coaster, and as your cart is moving forward on the track itself twists through some hidden dimension and loops back to the exact boarding station, literally 5 minutes before you even got in line. That is exactly what a closed time-like curve is. It's a path that returns to its own past. So how could we ever actually build that roller coaster? Well, Einstein's math does allow for something called a wormhole. I want you to picture the entire universe as a flat piece of paper. Now take that paper and fold it in half, so two completely different distant points are suddenly touching. If you punch a hole straight through those touching points, boom, you've created a tunnel, a cosmic shortcut.
If you were to set up this tunnel just right, balancing gravity and speed, stepping through it wouldn't just take you to a different place, it could actually pop you out at a completely different time, including the past.
Section 4. The Grandfather Paradox, the villain of time travel.
Now, you might be wondering, if the math says tunnels to the past might be possible, why don't we see time travelers walking around right now? Well, it's because of a massive logic problem known as the Grandfather Paradox. Think about it. What would happen if you built a time machine, went back in time, and accidentally stopped your grandparents from ever meeting? If they never meet, one of your parents is never born. If your parent is never born, you are never born. And if you were never born, well, how could you have ever built the time machine to go back in the first place?
This paradox is a massive headache for physicists because it breaks what we call causality, which is really just the simple rule that a cause has to happen before an effect. I mean, you can't eat a scrambled egg before you crack the shell, right? If traveling to the past allows an effect to happen before a cause, it completely shatters the logical chain of history. And because the universe seems to really hate things that don't make logical sense, a lot of scientists believe traveling to the past must just be entirely impossible.
Section 5. The Quantum Solution, Solving the Mystery. So, the crucial point is,
We're left with this crazy standoff. The math says time loops are possible, but logic says paradoxes are strictly forbidden. Luckily, modern physics has a few ideas on how to solve this. The late great physicist Stephen Hawking proposed something he called the chronology protection conjecture. Basically, he suggested that the universe has its own built-in security system. He believed that the very laws of gravity and quantum energy act as the timeline's personal bodyguards. So anytime a wormhole or a time loop tries to form, this quantum security system will rush in, build up infinite energy, and just destroy the time machine before anyone can even use it to cause a paradox.
but what if the time machine doesn't get destroyed? Well, a physicist named Igor Novikov came up with a totally different solution, the self-consistency principle. Let's break this down simply. Novikov basically said that if you go back in time, the universe will mathematically force history to make sense. So, if you try to stop your grandparents from meeting, your time machine might break down, or maybe you slip on a banana peel, or even crazier, your attempt to stop them might be the exact reason they meet in the first place. It's like the universe will playfully conspire to stop you from causing a paradox. You can absolutely be part of the past, but you can never ever change it.
Actually, our best clue yet might come from the smallest things in the entire universe: quantum particles. You see, in the quantum realm, things don't act like normal everyday objects. Particles can exist in multiple states all at once, which is a concept called superposition. Scientists have even run experiments using this wild thing called post-selected quantum teleportation to essentially simulate a particle going back in time. And the results? The math actually works. It turns out quantum mechanics might allow microscopic time travel, just as long as the mathematical probabilities always balance out to create a perfectly consistent, paradox-free history. So the timeline is safe.
So, as we wrap up this cosmic detective story, we've learned that traveling to the future, that is a proven scientific fact, and it's happening all around us. Traveling to the past, though, remains this beautifully complex theoretical maze of wormholes, quantum bodyguards, and self-correcting timelines. The universe definitely holds its secrets tightly, but every single day we get a little closer to understanding the true fabric of space-time. Which leaves me with one final question for you. If science eventually proves it's completely possible and the universe allowed it, when would you go?